Hello everyone, in this TRC tutorial number 25, we will see how to design a closed-loop amplifier of gain 1, even if the operational amplifier gain A cut the 0 dB axis with a slope of minus 40 dB by decade. Here we can see the classic follower schematic to get a unity gain. Unfortunately, if the gain A cut the 0 dB axis with a slope of minus 40 dB by decade, this schematic will be unstable in gain 1. What is the gain of this new schematic proposed? As usual, we use the superposition theorem. We start with Vin driving the inverting input with a gain of minus k. Then we use Vin to drive the non-inverting input with a gain of 1 plus k. As Vin drives both inputs, we have to add both results. Minus k Vin, then plus Vin plus k Vin. So Vout equal Vin, and gain Vout over Vin is equal to 1. The closed-loop transfer function analysis for the non-inverting schematic is as shown with Vf equal minus ak epsilon, where k equal r over kr plus r. If k equal 9, the ratio k will equal to 1 divided by 10, which means minus 20 dB. So the loop gain ak will shift of minus 20 dB. As the loop gain AK crosses the 0 dB axis with minus 20 dB by decade, the loop is stable. The closed-loop transfer function analysis for the inverting schematic is as shown with Vf equal minus AK epsilon, and both ratio uppercase K and K prime. Of course, for the studied schematic, we must take the closed-loop transfer function of the inverting input and add the direct non-inverting input of the closed-loop transfer function of the non-inverting schematic. The analysis starts with Vout equal A times epsilon. Replacing epsilon gives Vout over Vin is equal to 1 plus Ka divided by A times 1 minus K prime. If Ak is much greater than 1, Vout over Vin becomes K over 1 minus K prime. But as 1 minus K prime equal K, the gain is 1. In conclusion, the classic unity gain schematic with a follower topology is unstable because k equal 1, but the specific schematic provides a unity gain stable because the open loop gain is divided by 10 with k equal 1 over 10. The resistance R between Vin and the non-inverting input allows to get the same input impedance on both inverting and non-inverting inputs. So even if the amplifier has some leakage input current, the offset voltage will be compensated. This specific unity gain schematic has a gain of 1 even if k equal 1. By adding a switch S between the non-inverting input and ground, this specific unity gain schematic becomes an inverter of gain minus 1. So, if the switch S is closed when Vin is negative, we can transform this schematic in a rectifier. I want to thank you for your attention. On my next TRC tutorial number 26, we will talk about the diode rectification. So see you soon and stay tuned.